All right, so in chapter 10, we're actually going to take stuff we've done in chapter 7, chapter 8, and chapter 9, put it all together into new problems, right? So nothing we really haven't seen, but just haven't seen it in this context, I guess. So to start, in all of chapter 10, we're comparing two populations, whether it be two proportions, two means. Then we get into what we call paired means, or the matched pairs, which we talked about way back in chapter 4, right? So it's all coming together in these last few chapters here. All right, so first we're going to start off with kind of defining the sampling distribution for a difference of two proportions. All right, that's a very long title, but that's what it is. It's just difference of two proportions. So 10-1, we're just going to be dealing with two proportions, as you can see, and the sampling distribution, right? So, for example, when we looked at chapter 7, right, we had things like this, where, if we covered this part up, and we used, sampling distribution of P1 or P hat 1, right? It was approximately normal. We did NP and NQ, or N times 1 minus P, sorry. And they're both over 10, right? We knew it was approximately normal. The sampling distribution, the mu of P hat 1 is just P, the true proportion, which is 0.7, and we knew the standard deviation was P times 1 minus P over N. The reason you see ones there is because, say you did this again with a separate one. This could be like, over here you have school 1 and school 2, so you have two different schools. So you could say this is Pennsbury versus the Chamonix, or Pennsbury Council Rock, or two different schools. And here's your percentage, right? So your center. So instead of looking at these separately, like we have been throughout this whole course so far, we're actually going to combine that. And instead of looking at school 1 and school 2 separate, we're actually going to look at it as a difference, which we have talked about that before also. The difference, right? So we said we could take the mean, the center, right? If I look at the center, this is P hat 1 minus P hat 2. So this is the combined distribution, kind of like an idea of what the sampling distribution looks like. This one would have been, school 1 would have been centered around 0.7. This one's centered around 0.5. So instead, what we're going to do is look at it as a difference of the two. All right, I know we've talked about that before. So the center of this is at 0.2, which we can see is just P hat 1 minus P hat 2, right, which is 0.7 minus 0.5, and that gives us 0.2, right? So there's the center. And for the spread, right, we knew we added the variances, right? So we're basically adding these two together, but we got to square them first, right? So that would end up being the P hat 1 minus, P hat 2, right, would just be the square root, and it would be the variance of those two. So it would be P hat 1 minus P hat 1 over N1. That's the variance of the first one plus the variance in the second one over N2, and that would be that there, right? So what I could do is, let's take some of these numbers, right? So I take, or I can even just take these, right? So I take 0.0458 squared plus 0.0354 squared, and then square root those, or square root that, and you end up with a total variance, or variance, a variance of the, standard deviation of the differences would be 0.058. Okay, so typically what that's saying is that all these differences are going to typically vary about 0.058 away from the true difference, which is 0.2. All right, so remember, 0.2 is just a difference in the two, not what an actual value is that's coming from either of those. Okay, so that's really what we're getting at, with that, right? So you have your center, you have your shape, things we talked about before. So moving on to Then we can say, okay, so the center, the mu of p hat 1 minus p hat 2 is just the mu of p hat minus the mu of p hat 2. Make sure we label those, so we have that. Because if it's not 1 and 2, we're not really sure. All right, so that you have there, which is really just P1 minus P2 if you knew the true proportions, right? So that would be the center. We know the shape, right, would be approximately normal by large counts. If large counts is met. And that would be for both samples. Okay. And then the spread, right, we just went through that. And that was that the sigma of p hat 1 minus p hat 2 is equal to the square root p1 1 minus p1 over n1. And again, if we don't have the p1s and p2s, then we would have to use it for the p hats, right, that we talked about before. Right, and there you go. Okay, and even more so if you look on your formula sheet, right, you got it right there. Right, it looks crazy, looks a lot harder than it is. There's your two proportions, the center and the spread. All right, and then we're going to get into these standard errors in a little bit here. Okay, so there's the sampling distribution, right? So for example, we're going to look at one here. All right, so what is the shape of the sampling distribution? And that would end up being, so part A, this would be approximately normal. Okay, and the reason for that would be we would have to check all 4 of the NPs, and N times 1 minus Ps, right? So N1 times P1 would be, we'll say that would be the juniors, right? So 800 times 54%, so times 0.54, that comes out to 21.6. N1 times 1 minus P1, 800 times 0.46, right, which is, oh wait, I'm sorry, not 800, that's the population, my fault. What's the sample? 40 juniors, right? So there we go. Had the right answer, I had the wrong number plugged in. All right, so then 40 times 0.46 gives us 18.4, right? And then we have to do it for the other ones also. So we have N2, P2, N2, 1 minus P2, right? So yes, the conditions do take longer to check, but we do have to check them for both because it has to fulfill, both of them, or else we're spinning in circles. We're not really making any leadway. All right, so these all end up, and that's 35 times 0.51, so that checks out. That's 17.85, right? So all greater than or equal to 10, right? So that's how I would check for normality. Okay. Part B. This would be find the mean of the sampling distribution. So that's just the mean of p hat 1 minus the mean of p hat 2. And that would be 0.4 or 54 minus 49. So it would be centered at 0.505. All right. And then part C, calculate interpret standard deviation, right? So the sigma of p hat 1 minus p hat 2, right? That would be 0.54 times 0.46 over 40. That's the variance of the first. And then we have 49 times 5, 1 over 35. That's a variance of the second. Add up the variances, square root, and that ends up being 1155. All right, so that would mean that the difference, right, the difference in sample proportions of females typically vary by about, it's the same definition we used before, 1155 from the true difference of 0.05. All right. And there we go. Right. So that concludes part one. We'll get into the confidence intervals and significance tests in the next couple of parts here.